Okay, so last time we got together, we talked about writing out the equations of parabolas. And remember, there were two different ways to write the parabola and the equation of the parabola, and it depended on what kind of information that you had. If you knew the intercepts, the x-intercepts, then the easiest way to write the parabola was that y equals a times x plus or minus p times x plus or minus q business, right? Because those two values are the values of the intercepts. But remember, when you plug them in with the into the parentheses, or the brackets, sorry, into the brackets with the x, it's going to change the sign, right? Then the other one was when we knew the vertex, or the turning point. I'm going to always call it the vertex now. We did the y equals a times the x plus b squared plus c thing. Right? So we've got two ways of finding the equations of a parabola. We're going to use both of those methods today as well. But today we're going to add some things to it because we didn't have this plus c business on either one of these, and today we are. We're also going to talk about changing these parabolas, moving them around a bit so that we can describe them and compare parabolas and see what's different about them. Okay? So we're going to go back to all the topics, all the things that we've talked about with parabolas and how we can compare them and how we can describe those two parabolas in context, right? Now, this doesn't always show up on the test, but I have seen it on many of the NCEA tests where you're having to talk about these. So the first thing I want to do is go back. I'm on page 51 here, if you want to follow along in the book. So I'm just going to write some notes and then we'll talk about some of them. All right. Now, the first thing I want to talk about is a few of the terms that we've used. Remember that we've talked about the y-intercepts. I'm sorry, that I just wrote down x and said y. I'm going insane. So the x-intercepts. Remember, those are the places, the points where the graph, the parabola, crosses the x-axis. We've talked about the y-intercept. For these, there's only going to be one. That's where it's crossing the y-axis. So that point there. We've talked about the vertex, or the turning point. That's that point where it's turning. In this case, it happens to be the y-axis, just the one I drew. Okay? We've talked about that. Now, we've also talked about some things that happen to parabolas. We've talked about parabolas that are reflected. And remember, that's simply that one of them would have a positive A, the other has a negative A. So the positive A will open upward. The negative A one, if you change that sign, it would simply flip it over and make it open down. Know these terms. So reflected. Okay? We've also talked about what happens when you translate. If a parabola is translated. Translated means that it's moved either left or right. And remember, that's the one that's inside that parentheses or bracket. So always remember that when you do that, change the sign. So if it moves to the right, that actually, we would usually think move to the right as a positive number, but when you put it in that bracket with the x, it actually becomes a negative number, right? So it can be moved to the right 3, so that's x minus 3. So be very careful about the signs, okay? Then we've talked about about parabolas going about being narrow or being wider, right? Let's come to that one afterwards. Let's talk a little bit about the other one. Hold on just one second. Excuse me, just one second. Sorry, the joys of working from home. Okay? We can also translate a parabola up or down. And that's that plus or minus the C business, right? If it's plus, it goes up. If it's negative, it goes down. Okay? And then finally, the last thing we talked about was that they can be narrow or wider. Okay? So, and what happens there is that's where you have some A that's not 1, right? And remember, it's a little odd because if A is greater than 1, then it's going to get narrow, right? Because those numbers get steep. The numbers get higher faster, so that it gets very steep. But if our A is between 0 and 1, in other words, a fraction or a decimal, then remember it gets wider. Okay? So we've talked about all of those different cases. Sound familiar? Yep. Okay, good. Because now what we're going to do is we're going to put it all together and start looking at some parabolas and comparing those parabolas so that you can see what's happening to them and you can describe what's happening to them. So they're going to give you a parabola, you're going to look at the parabola and make some descriptions. Now there's one that we haven't really specifically talked about, but it's very easy, and that's talking about where X is negative or positive. So, remember, if you have a parabola, this is the x-axis. So anything above the x-axis is going to give you a positive x value. A positive value for the parabola, right? You're going above. Then down here, remember, if you go down, that's where the y's are all negative. It's the y values that make you moving up. Okay? So, pay attention to where things are, because we're also going to be looking at negative and positive in some of these as well. They're going to ask you some questions. So remember, below the x-axis, you're down in the negative territory. Above it, you're in the positive territory for your y. That means so you can easily tell those values. So keep that in mind as we go. And we're going to look at values that have x's and y's. So we need to be able to state where the values of x are positive and where y is positive or negative. So all this down here, that's y is negative because you're below the axis. If you're up here, y is positive. Remember, if you're on the right, x is of the y-axis, x is positive. If you're on the left, x is negative. Right? Because remember, if you move to the left, your x has to be negative. So along those axes are the cutting points that will tell you where things are positive and negative. Okay? All right. So what we're going to do is we're just going to jump in and look at some examples of what they want you to do and what they want you to accomplish here for each of these parabolas. Okay? Hold on just a moment. Let me find that section. Right? So x is equal to positive 1, and the other intercept is at positive 5. Okay? Now remember, if you were going to put those in the brackets, then that would mean that you would have to change those signs. Right? Remember, putting those intercepts into the brackets changes the signs. For the y-intercept is simply the place where it crosses the y-axis, and that happens where y is negative 5. Okay. The graph has a vertex or turning point, so that's going to the right 3, so that means the x value is 3, and then up, what is that, 4? So that gives you a vertex. Oops. Sorry, I'm answering the wrong question. That goes there. Okay. X is negative. y is negative. Y is negative. So remember, y is negative anywhere under the x-axis. So that's from where x is less than 1 and x is greater than 5. Do you agree that if x is less than 1, that makes the graph down there? If it's less than 1, I'm sorry, and if it's greater than 5, then that means all of those y points are down below the x-axis as well, making them negative. Okay? So just write it using an inequality. Right? Draw what the graph would look like if it were shifted 3 units to the left and 1 unit down. So if it was shifted 3 units to the left, again, remember when we're talking about those kinds of shifts, we're talking about moving the vertex. So all you're going to do to graph those, to move those, again, shifted 3 units to the left means 1, 2, 3. So there's our new vertex right there. Okay. Remember that it has that axis of symmetry. And so that axis of symmetry will tell you how wide or narrow the graph is going to be. And 1 unit down, so sorry, so it's not going to be at 4, it's going to be there at 3. Let me change the color here so you can see. So it's going to be there, 3 units to the left and 1 unit down. But that does not change how wide or narrow the graph is, it just changes the position. So if you'll see here, just using the intercepts as an example, okay, so, or we can go down one, let's see. We can use these 2 points. So from the vertex, 1 line down from the vertex, we're 1 line over and on both sides. So there and there. 2 lines we can't measure. Okay, so there's 1, 2, 3, 4 lines down we can, though. We can measure these 2 points. Those integral points mean, remember, of course, any points that you can actually measure. So 4 lines from our new vertex would be 1, 2, 3, 4. So there, and it's 2 points away this side, 2 points away that side. So there and there. And that's enough to give us a rough sketch. You don't need to get too carried away. They would have chosen more points, like there's another integral point there and there. But just remember that you can count from that axis of symmetry. Because whatever it's doing, it didn't get any narrower or any wider. So the points are still going to be, the points along the axis of symmetry away from the axis of symmetry are still going to be the same distances. It's only the vertex that is moved. Okay? So that is the messiest graph I've ever seen, but hopefully that makes sense to you. Next one I'll make it much bigger so that you can see a little easier. How does that look? Finding those points and describing it. Yes.
I'm just a bit confused on the y is negative where that little part there.
Okay, you bet. So let's look at that. So you can see remember that anytime you're going down, your y is negative, right? Well, that means any point below the x-axis, y is negative down here, right? Mm-hmm. Okay. Now, so that means y is negative along there, and y is also negative along there.
Yeah.
Okay. Well, so y is negative until we get to this point right there, and y is negative until we get to that point right there. And this point, this first one, is the point where x is 1. So if x is less than 1, that means you're down here in the negative territory. Mm-hmm. Then here, that's where x is 5. So if x is greater than 5, that means you're down here in the negative territory.
Okay.
Okay? So those 2 points are just giving you the stopping points, and they're always the x-intercepts. So if you look back at the x-intercepts, right?
Yeah.
So.
Thank you.
No problem. Anything else on that one? Looks good. Okay. All right. Then let's talk about the next type of question. We're going to describe in words how the green graph compares to the black graph, right? So we're comparing the green one to the black one. Okay, so let's just look at number 5. Well, first thing you notice is that, what do you notice about those two graphs? One is opening what?
And one positive.
Yeah, one's opening up and one's opening down, okay? So the green graph and the black graph, let's see if they give it to us in terms of which one. Hold on just one second. Just skip back to the answers so that I can, because I don't want to describe both of them if I don't have to. Sorry, all I have to do is find it. What is this one? This one's page 52. So the green graph has been reflected. So they're going to talk to it about about the green graph. Okay. So the green graph has been reflected. Right? Reflected means that it's flipped over. Yeah? But it didn't just flip over, it also moved, didn't it? Okay. So it has also been translated. Now, did it move? Did the vertex, remember the translation is always based on the vertex. Did the vertex move right or left any? No. But it did move up or down. So it's been translated up or down in this case. Again, we're talking about the green one. Down, right? If you look at the vertex of the green one, it went from here down to here, right? Ignore that little red dot, sorry. Okay. So it also was translated down 2 units. Did it get wider or narrower? Doesn't look like it, does it? But you can test by just looking at a few points. Let me just grab another color to look at those points. So let's say, we have an integral point here and here. Okay. Our line of symmetry stayed the same. So that's from the vertex of the original black line. That's 1, 2, 3, 4 units down. At 4 units down, it was 2 units away. So let's go, again, we're talking up from the green one. We're going to go 4 units up. So that's for there. And it's still 2 units and 2 units. So you see that because these things stayed in exactly the same position, it wasn't stretched. It didn't get wider or narrower. Okay?
Do we have to show that, or
no? You just have to check it to make sure you don't need to write it. Because if it had gotten narrower, you would need to have included that in your description.
Yeah.
Okay? So the green graph has been reflected, and it has also been translated down 2 units. I'll make sure you put which direction and how many units. Okay? Look pretty easy? Let's look at another one real quick just to make sure. Okay. This one's gotten narrower, right? So if that's x is 0, this one is higher. So you can find some units and decide and see what's happened. You can find it tells you that your A has changed, right? Because the vertex is still the same. So it's not reflected, right? It was not translated, but it's gotten narrower, or they call that steeper for some reason. This one has gotten steeper. Okay? So what we need to do is just find some critical points, or some integral points, that you can measure, and then see what's changed about them. So here is an integral point, right? That's the point on the graph. What is that? -5, +5. And see how that's changed. What's the next integral point here? Is there. So that's going to be, I'm sorry, well, we can't use -5 because -5 falls off our graph. We can't find out what it's doing at -5. Sorry. Let's find another integral point that's smaller. We can use this one. It hits both of them. You need to have a point to see what's happening at both of those. So you can see that it hits there and it hits there on both graphs. Let me just get rid of some of this stuff. And just see what relation those numbers have. Blue is really bad. Okay, so here again we have it hits there and it hits there. We can measure those two critical points. So for the black line, I'll just do that in black so that you know that I'm dealing with the black line. For the black line, that's the point -3, -3. Okay. But for the green line, that's the point -3, -1. Okay. So what we have to do is see what do you do to a -3 to turn it into a -1. Did it get bigger or smaller?
Bigger?
Well, okay, because a -1, okay, so let's see how they describe that. But you can see that all I did was pick some critical points to see where they turn, where they move.
Mr. Stealth.
Yes.
You know the black one, was that -3 and -3, or +3 and -3?
No, because we went left and then down.
Oh, right.
So -3, -3. Okay. So the vertexes stayed the same, but the green graph increases at 3 times the rate of the black graph. So what's happening here is to get from a 1 and a 3, that's 3 times as much. Yeah? So what's happening is this graph is 3 times faster, steeper than the other one. Okay? Right? So just find out what number. So just take the two numbers and divide. Now, if that was reversed and you were looking for the wider one, okay, it was making it narrower, that means you would be dividing, which means you were looking at a fraction, right? But this one, the green line is getting narrower. So remember, if it's narrower, it's going to be a whole number. So just take these, to find any two integral points, okay, and then see what you could do to one to turn it into the other one. To turn a 1 into a 3, you'd have to be 3. It's 3 times. Okay? So it's steeper by 3 times as much. Okay? And again, we know it's a multiple of 3, a whole number, because, again, it's getting narrower. And remember our discussion last time, that's how they get narrower. All right? So just find any integral points will do that. It doesn't matter where they are on the graph. So you could use integral points there, but I can't use this one because it's got to be able to hit both graphs, right? So that's why I had to change from that first one that I chose. I couldn't use it because it didn't hit the green graph. All right? Let's see. Now the last thing is they want us to look at what happens to the equation if you move things around. Okay? All right, so just look at number 3. to determine what happens to the equations, the first thing is you'll notice that every time we've done one of these, it's been in this form with the brackets. And remember, we described that. What does that mean that has been done to the equation if it's already has the brackets? We'll do two of these. We say it's been what? Oops.
Factorized?
Factorized. There you go. There's the magic word. Factorized. Exactly. And so in order to work with these, to make these, they need to be factorized. Now, so that's your first step, is to make sure they're factorized. We'll go ahead and do one that is factorized. Here, we'll do number 2, okay? And then we need to see what happens inside the brackets. And then finally, we need to see what happens if it has C, which is that thing that moves it up or down, right? So brackets, those are the things that move it right or left, yeah? They move the x-intercepts. The C, that plus C business, is the thing that moves it up or down. Right? Now also remember though, if you're talking about right or left, when we put that number in the bracket, it's going to change its sign. So if it's right, it actually is a negative. If it's left, it's actually, you're going to put in a positive. Okay? So those are your 3 steps. It has to be factorized. Then you're going to see how the brackets change. If they do, then you're going to see if it's up or down. Then the last thing is check your A, because it could also be flipped upside down. In other words, reflected, which means your A turned from either negative to a positive or positive to a negative. So did your A change signs? Okay. Also, did it get narrower? Or wider, which means that you have a multiplier. Now, a lot of this just seems like we're doing a bunch of busy work, but I'm telling you that when you see the applications, you're going to see that this kind of thing is used a lot in the applications when you're comparing two parabolas and answering questions from the applications. We know that this got narrower, and that means this, or it got wider, and that means this, right? If it's half of the original parabola, that means it got wider, right? Because half is a number less than 1, between 0 and 1. So you're going to see, and again, we're going to do the applications next time, so you'll see where you're using this. So now we're just practicing the busy work kind of thing, the how they affect each other, and then we're going to see the why later. So don't discount this. This is very important information. Okay? I'm going to get rid of those notes so that I can do this one. What happens if y equals negative x times x minus 2 times x plus 4 if we translate it 5 units to the right and 4 units down? Okay? So 5 units to the right, this means it's going to go that way 5 units, but remember that when you put it in the bracket, that's actually a negative 5. Right? Remember, you put it in the bracket, it changes it. And then we go 4 units down. 4 units down is still negative 4. Okay? So we didn't reflect it, so it's still going to stay negative. We are changing what's inside the brackets by negative 5 for each one of them, and it's not just one of them, it's both of them. So x minus 2 minus 5 is what that becomes, and we'll simplify it in a minute. I'm just going, and you don't have to write it out in as much detail as I do, but I want you to be able to look back later and see what we did. So x plus 4 minus 5, and then it went down 4, which means we're subtracting 4 from the whole thing. Now it's just a matter of simplifying it. Negative 2 minus 5 is negative 7. x plus 4 minus 5 gives us x minus 1, and it's still x minus 4. So if we move it according to those directions, that's our new equation. Okay? So just using the things that we've done, but we can write a whole new equation without having to look at anything about the graph. We don't even have a graph there. Okay? All we've done is write the equation. Now, if you want to graph it, I don't even know if they're asking you to graph these. I'll look back up at the top directions in just a second. But you don't even have to have the graph in order to be able to rewrite the equation. Just know what these things do to where. So if it moves 5 units right, that's a -5 inside the bracket. So I put a -5 in each bracket. Down 4 means that we have that plus C business at the end, so -4. Look okay?
Yeah.
Yeah, okay. So it's not difficult. You're just probably wondering why. But again, when we get to the applications, that's when you're going to see why.
It says that we have to draw the original graph and then draw the translated one and then write that equation.
All right, so they do want you to graph both of them. Great.
Yeah.
Okay. Well, you can do that. Remember, all you need to do to graph these, so like if I'm going to graph this one, x minus 2, that means your first one is there. X plus 4 gives you another one there. And then halfway between them is the vertex. So what is that? 1, 2, 3, 4, 5, 6 units. So 3 units is the line, the axis of symmetry. And so that's where x is equal to -1. So plug x equals -1 back into the equation, and you can find the y, and that's enough to graph it. So y equals -1 minus 2 times -1 plus 4, -3 plus 3, which makes that +3 plus 3, which is 9. So that means our vertex is here. And that means our parabola is doing this business. Not pointed like mine, be neater than me. Okay? And then you can either plug in numbers and move it, or we can simply move it. It's 5 units to the right, 4 units down. Okay? I've made a sign error somewhere. Can anybody tell me how I know that?
Isn't it supposed to be negative?
Yep, it's supposed to be going down, so I've made a sign error somewhere here. It should be +9, so that means that it should be up here, going down. Because my original equation should have been opening down, not up. I did it the wrong way. Okay? But it's easy to tell because I knew that it should have been opening down. Okay? And then just move it according to the pattern they give you. Okay? So you could rewrite it if you wanted to, and use the math to do the new one, or you can simply, once you graph it, then you know it's going to just move 5 to the right, 1, 2, 3, 4, 5, and then down 4, 1, 2, 3, 4. There's your new vertex. Okay? And your x intercepts will just do the same thing. Every single point of it will move because it's that same amount. So 5 over 1, 2, 3, 4, 5, 1. So it's going to be there. And 5 over 1, 2, 3, 4, 5. So they just slide over. Okay? And then down. Right? But you have your new intercepts there. Okay, let's look at another one of those. See if I can do it without not turning it upside down. All right, here we go. Y equals -x squared plus 4x. What do I know about this already without thinking about anything else? It's opening how?
Down.
There. Let's get that out of the way. This one is not factorized, though. But it's an easy one to factorize because all that there is there's a common factor of x. But remember, anytime you factorize it, if there's a negative in front of it, we're going to factor that out. So factor out a negative x. That's going to make that x. Positive 4x divided by negative x is just negative 4. So we want that negative outside. So if the first term is negative, then factor out a negative x instead of just an x. So all I did was factor out the common factor of x. And we can set each one of those equal to 0 to find the vertex, to find the x intercepts now. And you don't have to show the math if you don't need to. So right now, it's positive 4 and 0. So that gives us an axis of symmetry at 2. So that's y equals, and you can go back, since you have this one, it's nicer to use that one than it is to, so negative 2 squared plus 4 times 2 gives us negative 4 plus 8, which is 4. Good grief. So positive 4. Okay. So up 4. 1, 2, 3, 4. So there. So that's my original graph. Right? Then all I have to do is think about what they want us to do. Translate it 5 units to the left and 3 units down. Again, you want your factored form for that. So 5 units to the left means we're going to do minus 5 to both of them. So that's x minus 5, x minus 4 minus 5. Oops, I'm sorry. To the left means I'm going plus 5, right? So that gives me negative x plus 5, x plus 1. But we also went 3 units down, so that's subtract 3. So there's my new equation. Okay. And then I simply graph it. How does it look?
Beautiful.
Beautiful. Well, I'm sure it will be beautiful when you do it. My graphs are a little wonky. But, okay. So what if I say 6 units to the right? Is that going to be add 6 to each one of the parentheses?
Minus 6.
Minus 6, exactly. What if I say 5 units to the left? It's going to be add 5. Good. What if I say 10 units up? That's just add 10 at the end of the equation, right? That's that number at the end. Okay? So up is add, down is subtract, just like normal. It's only when you're putting numbers into parentheses or into brackets that it ends up changing their signs. Okay? Now, again, once you get a new equation, you're changing the whole equation, so you're going to get new intercepts and a new vertex, right? So you'll have the same shape of graph, so it won't get any wider or narrower because our A didn't change, right? It's still negative 1, but your intercepts are going to be in different places because you're moving the graph. So this one's 3 units down, so that means, and 5 units to the left, so that's easy. So x plus 5 gives us a new, let me just change colors so we can do this one. So x plus 5 gives us x minus 5 for the new x-intercept. X plus 1 gives us negative 1 for the new intercept. But notice that they're still the same width. That's not going to change. So if the width changes, then you've got issues. Okay? Now, our new vertex, still in the middle. 1, 2, 3. Okay? It just went down 3, so 1, 2, 3 down. Okay? So our new axis of symmetry is over here now because we've translated it. That's where x is equal to -3. So just plug it into there. Y equals -3 squared plus 4 times -3. It's 9. -9 minus 12 is -21. That's way off, isn't it? What did I do?
Don't we use the other equation?
Yeah, that's what I'm doing. Oh, you know what the saddest part is? I record all of this ignorance, so you see how you can see my silly mistakes. So it's negative, and again, it's a negative, what is that? That's -3 again. So -3 plus 5, -3 plus 1, minus 3, gives us -2 times, it's minus a positive 2 times -2 minus 3. 2 times 2 is -2 is -4, plus that is 4, minus 3 gives us 1. So it's right there. And again, we could have just counted down. Oops. And nope, we're still negative. Okay? Alrighty. Don't do what I do what I say, clearly. And make those work. All right? So, the big deal, though, is make sure you know translations mean that it's moving right or left, up or down, right? Reflections mean you're flipping it across. It can get wider or narrower. If it gets narrower, that means it's a whole number, a multiplier that's a whole number. If it gets wider, that means it's a multiplier that's a fraction, okay? And the big deal is that if you plug that number, if it says 5 units left, we usually think of left as negative, but actually that means add 5 inside the bracket. It's good?